Welcome to Daddy's Podcast.
This is the Redefining Plastics Podcast. Welcome to the Redefining Plastics Podcast. My name's Justin Riney. Got a guest today, Camilo Ferro with Raws. We're going to talk a little bit about new technologies and new outlets for plastics. So, Camilo, welcome to the show. Why don't you tell the folks a little bit about yourself, who you are, and what is Raws?
Yeah, excellent. Thank you, Justin, for having me on today and giving us the space to talk about this innovative technology. As Justin mentioned, my name is Camilo Ferro, and I am part of the Raws team. Raws technology is a brand new technology. We just received a U.S. patent at the end of 2022, and the technology stands for Returns to Air, Water, and Soil. And to summarize, essentially what the technology does is we chemically change plastics. When a plastic is no longer going to serve its purpose in its usage, and it's not going to be recycled, and it's going to go to a landfill, we're chemically changing the plastic. So it's a technology that gets added to the plastic pre-extrusion. It can be injection molded, it can be thermoforming, it can be blown film. Any way we're going to make a plastic, you add the technology to the plastic, and when that plastic is now being converted to a plastic bag, a diaper, any of the vast usages that we have for plastics, that product will be 100% biodegradable. That's in short what the technology is, and obviously we'll dive a little bit deeper into it.
Yeah, because I got a ton of questions, right? The first thing I hear when I hear anything like that, I think oxo-degradable. I think just breaking material down into smaller pieces. So ultimately, you're talking about taking it back to like biomass, right? That's what we're talking about. Like that's all that's left. Like there's no polymer left at the end of the day.
That's exactly what happens, Justin. And thank you for bringing up the oxo-degradable, because that's always a conversation naturally we have day in and day out. The technology, one, we don't fragment the plastic. So we're not breaking plastic apart where all of a sudden you end up with microplastics. We're diving into the actual chemistry of the plastic where we're chemically changing the plastic. So we are breaking it down from your polymer, lowering the molecular weight down to a monomer, and the process continues to go to eventually what remains would be this biomass or ketones and aldehydes that are all part of the carbonyl group. And that's what we do. That's what the technology does.
So is this like a free radical system, or you want to talk a little bit about whatever you're comfortable with sharing? You want to talk a little bit about the technology and maybe how it works without divulging any proprietary information, obviously?
Yeah, no, of course. So it's we utilize a thermal degradation pathway. So we use free radicals. You nailed it. We utilize the free radicals to start depolymerizing that polymer. The big difference between us and oxo-degradable technologies, or even some of the technologies like enzyme-mediated technologies, is where we will work aerobically and anaerobically, and we don't need the oxygen nor the enzymes to start biodegrading the plastic. We only need two components to this: is thermal. So we need at least 77 degrees Fahrenheit, which is pretty warm. And when we look at landfill temperatures, across first world countries and properly maintained landfills, for the audience to know, it's anywhere between 90 degrees Fahrenheit and all the way up to 140 degrees Fahrenheit. So the heat in a landfill is very high up. So the technology, as long as we have 77 degrees Fahrenheit and some humidity, technology is going to get activated. We're going to start attracting those free radicals and going to start depolymerizing the plastic.
What about the before? Like if you're making a bag and you're walking around, it's 77 degrees outside, is that going to start depolymerizing while you're walking? Like what's to protect that product before like it hits the window when you want it to start to break down? Like when it gets into a landfill? Because obviously my goal is to keep it out of landfill. And I don't think you're advocating for putting stuff into a landfill. You're just saying that if it's going to end up in a landfill, let's have this stuff in there so it breaks it down, so it just becomes biomass, so it's natural at the end of its life cycle.
That's correct, Justin. We want recycling. We want recycling to continue to take place. But we're aware that a lot of these plastics, one, don't get recycled or don't end up in the proper recycling stream. And where do they end up? They're going to end up in a landfill. So in that scenario, when that happens, you have a technology now, when it does end up in a landfill, is going to completely degrade, not leaving any microplastics behind, leaching out into the potential environment. Back to your earlier question on kind of how do we stop it from me walking around from a grocery store, or it's starting to rain and all of a sudden the bag completely rips on us, like happened last night with the wife and I. We had some Chipotle and some of the salsa was going into our paper bag. We got out of the car, disaster. Chipotle bowl all over the place. My wife's quesadillas were on the street. It was a mess. So we want to avoid that.
The worst for food takeout. I cannot with paper bags for food takeout.
It was a disaster. But knowing that, to avoid that, what we do with the technology is we have a stall date. So we're able to create the technology to give us a stall date between 6 months all the way up to 4 years. And we have some customers now that have asked us to start testing it up to 6 years. So the technology won't get activated plus or minus 3 months from that stall date. Follow-up point to this, how do we do that? We're able to adjust it with proprietary UV blockers and thermal blockers for the technology, depending on where the product is going to end up.
And those will start to break down over time. So as I'm assuming it's a master batch. So as that master batch starts to break down over time, then that UV protection will then be gone, right? And then it will start the process. So that's from a high level, correct. Very unscientifically, that's what we're talking about. I want to make sure everybody understands what we're saying here.
Very high level, that's the way it works with live testing that we've done. Like, for example, mulch film. We know mulch film, issue with plastic mulch film, how much we need it for our crops, right? We need it. We can't get away from it. But we also know that a big problem with that is the mulch film that ends up lasting in the farm once the crop has grown. We have been very successful in adjusting the film to last different temperature ranges and different time ranges based on the actual crop that's needed. And we're able to do this by also adjusting some of the UV blockers, seeing that 10, 11 hours under the sun. We're adjusting it accordingly based on what the customer and the crop yield is needed.
You guys running into anybody challenging you on this, like pushing back, saying, hey, that's going to be microplastics? Or are you running into any of that? Because that's the first thing that I think of. And I actually know more about this than most. And I can only imagine if you're talking to regulators or you're talking to brands, that's going to be the first thing that's going to pop into their brain.
Oh yeah. Yeah. So a little background, Justin, on the technology too. And, the technology, it's been around now since 2018. The technology was first created in 2018. We applied for the patents in 2020, and then we started getting the patents in 2022. So we now have approximately 5 years of testing data and scientific data that verifies that no microplastics remain. And that is naturally the biggest concern when we first got introduced to the technology is how do we actually prove this? You're telling us that you're eliminating microplastics, but give us the data. Show me the science that actually tells me that this is what you have. And that's what we've been able to go do.
Okay.
So as you know, as far as not microplastics verification, that it is still fairly newer in the world, right? Of people understanding what it is and then how it's going into our brains, our lungs, etc. There's very few testing protocols and processes to follow. The one that is very prominent is an ISO standard. An ISO standard called 24187. It's so new, it just got finalized at the end of 2023. And we follow those specific ISO standards that verify no microplastics remain. Now, they utilize some of the standard machines you're going to be aware of, and some of your audience is going to be aware of, like a FTIR, GSMC, a GPC, and different spectrometry range machines, for lack of a better scientific word. So we do follow those ISO standards, and we do take it one step further, and we have partnered up with Northern Illinois University to continue to follow up and test these remnants that verify no microplastics remain.
There's so many different ways we can go with this conversation. But I think the one thing that always comes back from like a packaging perspective is, what does this do to performance on any kind of application? So if I'm making a plastic bag, we've talked about that a couple of times. Is that going to degrade the performance? Am I going to have the same kind of tear resistance? Am I going to have the same kind of strength? Because I'm assuming it's a very low letdown. And letdown, for those that don't know, that's the amount of percentage that you're going to put this product in a blend to make the finished product. But my assumption is that there's really no property changes that are going to be to the finished product because you're going to put it in at such a low percentage. But have you checked that? Have you done any kind of testing to see if there's any kind of change from a property perspective?
Yeah, Justin, that's correct. With it's a 1% letdown that gets added to the 3 types of plastic we currently work with. So we currently work with polypropylene, polyethylene, and any of the derivatives to the olefin family. And then we work with PET. And it's all at a 1% letdown. It does not affect any of the characteristics, tensile strength, coloring of the plastic during that process. The only time you're going to start seeing the effects is once we've started to degrade the actual product itself. Before the degradation, you won't see any effects of the technology. Just to give you an idea, and for the audience that's looking at us visually, if you're hearing us, you won't be able to see this, but just to give you an idea on the technology itself. So this was a 7-layer fruit cup that was created in June of 2022. And if you can see closely, I'll try to tie it into as much as the camera. The technology has already been activated. So we're chemically changing the plastic. You can notice the cracking that's starting to take place on the cup. But more importantly than the cracking, that's important, but this is 7 layers. The layers is starting to strip apart. Now, this was done almost 3 years ago, and it was in our office with over 77 degrees Fahrenheit, and it's starting to do its job. If the fruit cup was in distribution, it was in its closed box while it was going through the process, you wouldn't see any changes to the product until it needs to start doing it.
So my background is in films. So I'm curious, have you looked at adding this technology into any kind of bond layers, like between like a multi-layer flexible film, where then they could start to break apart at the end of life? Because just you pulling that apart right there was like, maybe we can find a way to like break these films back into their different structures, because, monofilm's great. I like the idea, but there are some applications that high density polyethylene is not there yet. So we can't do like the same kind of barrier that we need. So maybe there's a way to take this kind of technology and have the layers break apart at the end to make recycling easier. Is this something you've looked into at all?
We've looked into multi-layer packaging, and we can completely break down multi-layer packaging. That's similar to the fruit cup that I showed. We have done packaging in the past for 7-Eleven in Hong Kong, a multi-layer packaging for 7-Eleven. So naturally EBOH and BOPP. And here in the States, we do have some commitments from a fairly large CPG company that's starting to trial out some of the BOPP packaging with multi-layers for them. As far as breaking down that polymer and then utilizing some of the monomers back similar to like what chemical recycling could do, that'd be some of the testing that we'd have to go down the path, which we haven't done.
I was just curious. Like,
yeah.
These are things that pop into my brain when I see people pull layers apart.
Oh yeah. Well, you're in the industry, right? And you see this day in and day out. So you get the fresh ability to brainstorm or come up with different ideas on how we can do this. One of the important points that I like to bring up, and because we mentioned recycling, the technology does not affect your recycling stream. So if you are going to utilize recycling, if you want to use, let's say a t-shirt bag or a recycled polypropylene container, and it's got the technology in it, when that container goes to the recycling system, it can still be recycled.
Does it burn off? Do you have to repelletize it though?
If you wanted to re-add Raws material to the recycled pellet, yes, you would have to add that 1%. It does burn it off because of the heat of recycling, it's going to completely dilute the additive away, and it's at that 1% letdown. So we melt it completely.
So as long as it's re-extruded at some point. So if it's being made back into another bag, it's going to have to go through an extruder again. And you're saying the temperature within the extruder is going to burn off the additive that would break down. So then you can recycle it. So you don't have to worry about it contaminating recycle streams. Because that would have been one of my next questions. It's like, how does this impact something that we want to make circular? Like it for some reason it ends up in the recycle stream. I want to make sure that recycled product's not breaking down in 2 weeks because there's some kind of additive in there.
The temperature that we're melting or recycling polypropylene, polyethylene, and PET is so high, it just melts the technology away. And then once you have that recycled resin, if you wanted to, let's say, use your 30% recycled resin, 70% virgin, if you wanted to make that plastic, again, completely biodegradable, you would add that 1% raws to it to continue that process again.
Where are you guys at? Like on scale, production? Is this all lab work? Are you currently commercial? Like, kind of give us a little breakdown, like on a status of where you're at today as far as a company.
Yeah, as far as the company goes, so we launched into the U.S. marketplace in approximately 2023, soft launch, and then really had an aggressive push into the market in 2024. Once we received all of the different data that we needed, and scientific verification, we got into a major grocery store in the Northeast where they were using some of our produce bags, and their technology was in the produce bags. And then from there, we started having conversations with some Fortune 500s, Fortune 1000 companies, both on the brand side and on the resin side. And today we do have a couple of larger organizations that are testing out non-woven polypropylene for diapers. Diapers being, for example, a perfect solution for this type of technology. We know
you're not going to recycle a diaper.
You're not going to recycle a diaper. And we look at what are the contents of diapers, right? Polyethylene and polypropylene.
Yeah.
So we can completely break that down. So we have a large brand that's currently testing their non-woven right now with the technology. And really good news, we're getting some great results on the biodegradation already anaerobically. So that's exciting. Mentioned earlier, we do have a CPG company that's committed to start testing on their product as well. And then we're finalizing some other testing with some other food service items and hardware items as well. So we're definitely generating momentum, gaining traction, and more importantly, we just received our latest testing result that proves a 0.5 nm plastic sheet. So it's a pretty thick piece of plastic. Anaerobically, we degraded it in 996 days.
Okay.
Complete degradation, 99.62 CO2 release. No methane was released. The only methane that came out of the testing was based on the soil that was used as an oculant.
Where my mind goes, because I'm a home composter, is this something that if my home compost is hot enough, it will break down over time? But I'm guessing, so I'm not in a tropical climate, obviously, so it's not 77 plus degrees year round. If it is in there in the summer and then it gets cold in the winter, what does that do? Does it just stop the process? And then once it gets warm again, then the process begins again? I guess these are the kind of questions that I have, because if I wanted to take something like that and home compost it, I don't like the idea of it taking 900 some odd days, but like, let's just say I wanted to. Is that something that you've tested? Is that possible?
Yeah. So on the home composting side, kudos. I'm a home composter as well. Love composting, and actually kudos to all the community composters, because you look at the folks that are picking up the compost from our buckets. I'm calling them from the city of Chicago. I'm in the middle of the city and I'm able to compost day in and day out. So, and it's through these small businesses that are going around there and picking up the composting. So kudos to them. But yeah, so back to your earlier question, not to go into composting too much. But yeah, technically the product will compost in your home compost and in an industrial compost. because we're doing the same process that a PLA product is going to go through, right?
Yeah.
Once that process of degradation happens, we're changing the chemistry. That's simply what we're doing. We're changing chemistry. So because we're changing the chemistry and depolymerizing it, that piece of plastic will compost in your home compost or your industrial. It's just not going to get it at the time that you want it, right? It's not going to get it and when you look at ASTM or BPI, they tell you 90% within 180 days in their facilities. That the technology is not meant to do that. We're meant to have a longer shelf life for products that we know, one, are really never meant to be composted in the first place. Yeah. And then two, that are not going to get composted, right? Those are the products that we know we want to really work with because they don't have other solutions out there.
I like looking for new solutions for things that don't have them today. How did you get into this?
So coming back to composting, I've been in the packaging industry since 2009. I started a composting bag business. Okay. So back in 2009, 2010, that was really composting and compostables were barely ever being talked about, right? So I was closing up an old business that I had due to the economy turning in 2009. Long story short, like every entrepreneur goes, not everyone, but a lot of entrepreneurs go through this. What am I going to do? Cars being repossessed, being evicted from my apartment. I mean, the list goes on. And I came across this concept of biodegradable. And then I started doing my research and I started understanding what was biodegradable and what was compostable. So I put a business together where we were importing compostable shopping bags into the marketplace. In 2009, 2010, and I started getting involved with Chicago City Council, started getting involved with different municipalities that were looking to do bag bans, but pushing and understanding that compostable bags was going to increase composting and help develop more composting and increase the infrastructure of food scrap diversion, because that's what composting is. We got to divert our food scraps. So through all of that process, started building the business, started getting some national distribution. I got to a point in around 2018, 2019, I ended up making a bad business decision, and I had to get away from that industry, from the compostable bag industry. But it was still had my foot on the pulse or thumb on the pulse in the food packaging world. And through relationships, I got introduced to this technology in approximately 2020. And through time, doing some research and due diligence, like any of us, right? Understanding, is this real? Does this really do what it says it does? And
because it does sound like a unicorn. It sounds like a silver bullet. And to be completely candid, I've had these type of conversations on these kind of products for 10 years now. There was a company out of Canada. There was a company, I forget where else. And then they never seem to go anywhere. And so I always like to know that, it still seems to be viable to some extent, and that you guys have testing and you're still working this angle. Because I do think there are products that, diapers are a great example. You're never going to recycle it because of what goes into the diaper. And there are other things like that just will never be recycled. And so we need to find a solution for it. So I like that idea. It's just a matter of, I think you're going to run into a lot of skepticism because it sounds too good to be true. It really does. And so that's why I ask these things. My next question is, are you like an owner there, or are you just an employee, or how does that all work? I'm curious.
Yeah. So we can talk about the skepticism because that's something we deal with every day, right?
Yeah.
But yeah, to answer your question as far as ownership, yeah. So our group, we're considered Raws Americas. Our group we have the distribution rights to the technology on this side of the world. So North America, Central America, South America, and the Caribbean. I'm one of the partners of that group.
Where's the corporate at? That was my next question.
Yeah. Raws corporate is out of Hong Kong.
Okay.
Hong Kong. Currently, today, the technology is being made in China and Thailand, and we're in the final processes of finalizing American compounding. So we'll start compounding in the U.S.
You're ahead of all my questions, because my next thing was going to be, what about assets? Like, are you third party producing all of this? And apparently you're third party producing all of this. So
with the process of, kind of understanding manufacturing and understanding, okay, we start looking at nearshoring, we were able to concentrate significantly the formula, and we're able to compound easily, making it more accessible to where we're selling the product.
I know you said you had some comments on the skepticism. I'd love to hear your response to the skepticism, because I got to be honest, like, I keep hearing these things and I don't see it. I haven't seen it scale yet. So I would love it too. I really would. But what is your response to my skepticism?
I welcome it, Justin, 100%, because, and this is the skepticism that we hear every single day. I was just as skeptical when coming from the composting industry.
Yeah.
I spent a decade of my career and providing for my family, selling compostable packaging, selling composting, selling that this is a solution, and still a proponent of it, still a supporter, still sell compostable packaging. So that's definitely different, but we need to look at innovation. We need to look at technology and understand that with innovation, there are solutions in the marketplace like this, and we have the science and the data to back it up. Because that's the thing. If I didn't have the data and I didn't have certification in science to back it up, then the skepticism, it's always going to be a little bit more, and it's harder for us to challenge that, or at least go and provide evidence. But we have all the evidence now that helps eliminate some of that skepticism. Is one, by strictly looking at the data, looking at both lab data and real world data. And then one of the things that I do, I mean, naturally we can't do it here because we're having a conversation virtually. But if you were to take a vial and smell some of the plastic that's already started to go through the process and degrading, your skepticism would start going a little bit less, because you're going to smell the acid and you're going to start smelling the degradation taking place. So for us, yes, it's a higher mountain decline because of, unfortunately, some of the previous competitors, previous technology couldn't prove what we now are able to prove. But we welcome the challenge. We have the data. And I always like to compare, to kind of think about where were electric cars 20 years ago, 25 years ago. There was that big, is not going to work. It's not going to work. This stuff doesn't make sense. And now I don't know the data. I don't know the stats on how many electric cars are out there, but there's a lot.
It's not growing like it used to, but it's still growing.
It's still growing. And for us, it's like, let's look at technology and innovation, and let's not let perfection be the enemy of good. And understand that with innovation, there is some good out there, and we can go towards it with proven data. And that's what I
think the difficulty with yours, though, is if you don't have perfection, and you're going to have some sort of microplastics if it's not doing 100% of what you say it's going to do. So that makes it a bit of a challenge. When you're doing your testing, and because you've spoken a lot about the different testing you've done, is that internal testing, or is that like a third party certified testing? What is the testing protocol that you're doing there?
And thank you for asking that, Justin, because it's very important to know everything has been third-party verified, third-party labs, and they are all under the ILAC umbrella. So either directly certified under ILAC or through ILAC's partnerships, they are following the ILAC processes and frameworks.
All right. I got a stupid question for you. What is ILAC?
International
I've been in plastics a long time. I've never heard of ILAC. Yeah.
Oh, so it's the International Laboratory Accreditation Corporation.
Got it.
So basically making sure your labs are being run the right way, done the right way, following the certain processes. And I bring that up because in talking in some of these South American countries and in other Central American countries, that's an important piece to them, is making sure whatever labs we are using, they are accredited and following the certain processes and protocols. I'm glad I stomped you on one.
It happens more often than you think. What got you into the degradable plastic space, but before that, compostable? Like, there has to be some sort of an environmental drive there, because it seems like your businesses have been focused on environmental challenges so far. Like, what drives that? Like, what got you there? Is that just something that you woke up one day and you're like, hey, that looks like a good business? Or is it something that, like, there's some experience there that has driven you down this path?
the first thing that I can recall as a kid, growing up in South America in Colombia, outdoors all the time. We grew up on the farm. We used to grow up outdoors all the time, and it was always important to kind of reduce and reuse as much as possible. But when coming back, when I used to play soccer, came back into the States and growing up in Miami, I was always a kid that stayed after soccer games and soccer practice, picking up the Gatorade bottles, picking up the little green cups that we used to drink. And I was always conscious of that, of just not letting litter out in the street or out in the park, after we were done with the soccer game. So that kind of just stuck with me growing up. And then when I got to the opportunity of just business and starting my own business, it clicked. When I had to close a shipping franchise when the economy turned in 2009, and I was moving, I had to get out of my apartment. I was donating my pots and pans to a friend of mine. I had them in a shopping bag, like in a t-shirt bag. And when I went to move the t-shirt bag, it broke on me. So I needed another bag. And in that process, I realized, well, I'm going to reuse this plastic bag. And I reuse this plastic bag all the time. I reuse it for my shoes. I reuse it for the gym bag. I reuse it for swimsuits. And then I reuse it this time again for my pots and pans. And then that's what kind of struck the chord. The light bulb went off and said, well, I'm reusing this. What are the alternatives out there? How often can we reuse it? And can I sell advertising space on them because I'm reusing it? Yeah. And then one thing led to another, where I was able to start building an advertising agency selling ads on compostable bags in the city of Chicago. And we started building the business. We started getting traction. And at that point, there was an alderman in the city, and this is now going to 2010, 2011. He wanted to put a ban on plastic bags in the city of Chicago. Yeah. And at that, I was probably 24 years old. Had never talked to a politician in my life. I just went and said, listen,
you were better off before.
But I had the solution. I showed up, with suit and tie, and said, here's a compostable bag that does all the good things that we know plastic does, but it doesn't have the negatives that we're worried about. So let's see how we can get this into the market. And for the next 12 to 18 months, Justin, I spoke to all the aldermen in the city, went and testified in front of city council, even had the opportunity to get invited and meet President Obama at one point, to not necessarily talk about this, but through being entrepreneurship, et cetera. So long story short, not to bore all the audience on this story, but it was been over 14, 15 years of a passion for sustainability, and then just understanding it, and then realizing that we could do good business for good and for the environment and for our neighbors. And I just stuck with it and kind of continued to follow through.
So how do people learn more about what you guys are doing? You have like a website out there that somebody can get in contact, or I'm assuming LinkedIn, because that's how we got connected, right? But is there an easy way for people to find out more about your product? Specifically, there's a brand listening that has some sort of interest in learning more.
Yes, they can definitely visit our websites. It's rawsamericas.com. And you can also find me on LinkedIn under Camilo Ferro, and obviously speak with Justin and we can connect. But rawsamericas.com would be the easiest and most direct way to find us.
All right. And we'll put all that in the show notes so everybody's easily able to get in touch and find all that stuff. I typically let the guest have last word, last topic, anything we haven't covered today. Is there something that you really want us to know about the company or the products that maybe we haven't covered already?
No, I think, Justin, you've done a great job. Thank you for going through this, and for somebody who's had the experience of talking to different technologies through the years. I appreciate the space and the openness to be able to connect with us. We have a very innovative technology. We have something that's now proven, and now it's scientific validated. So we welcome all companies that are looking to find for solutions to help with their sustainability goals to reach out. And we're happy to go through this process. And testing it is very straightforward, and it's very easy. It's not a long-winded testing process.
I'd honestly love nothing more than for you to be successful at this. Like, if it all works and everything is doing exactly what you say it is, then by all means, I'd love to see you be successful and solve some problems, because Lord knows we've got them. And I'm real excited to see kind of where this whole thing ends up. But appreciate your time today. Appreciate everybody listening. This has been the Redefining Plastics Podcast. My name is Justin Riney for Camilo Ferro.
If you want to learn more about the plastics industry, recycling, check out these other videos.